We've previously considered the nature of vector addition, where we can describe any vector as the sum of any number of other vectors. We're now going to look at what is known as vector components. First, we'll consider vector A, where vector A is going to have magnitude A, and it's going to be pointing at some angle theta into quadrant 1, where theta will therefore be defined between 0 degrees and 90 degrees. A won't necessarily be easy to deal with, however, we can break it up into two components. The first is going to be AX, and we can see that AX lies perfectly within the positive X direction, and we're going to have AY, and we can also see that AY will lie within the positive Y direction. So while vector A may not be easy to deal with, we can see that vector A is equal to the sum of AX and AY. So anytime I need to deal with vector A, instead of talking about it as A at some angle theta, I can talk about it as A being equal to AX, how much lies in the X direction, plus AY, how much lies in the Y direction. And these two are equivalent. We know by definition that X and Y are at right angles to each other, so we can see we've created a right angle triangle. And with the right angle triangle and our knowledge of trigonometry, it's going to be possible to define our vector AX as going to be the magnitude of A multiplied by the cosine of theta, which will give us a positive number because theta is between 0 and 90, and we can see that AY will be A multiplied by the sine of theta, which will also give us a positive value because the angle is between 0 and 90 degrees. And so now we can break up a vector A at angle theta into its AX and AY components. So if I want to take vector B, which is going to point into quadrant 2, so now we're going to define angle theta, where angle theta, again based east is 0, is going to be greater than 90 but less than 180 degrees. We're going to be able to define an X component of B, so we're going to have a BX component. BX is going to be equal to the magnitude of B multiplied by the cosine of angle theta. And because the angle is greater than 90 and less than 180 degrees, that's going to give us a negative X component. We will also have BY, where BY is going to be defined the magnitude of B multiplied by the sine of theta. Because we have an angle that's greater than 90 but less than 180 degrees, we'll get a positive sine theta, which means that we're going to have it pointing up. We can continue now with vector C. Vector C is going to point into quadrant 3. So with east is 0, we're going to see that angle theta is now going to be greater than 180 degrees and less than 270 degrees. And so now we can define CX, where CX is going to be the magnitude of C multiplied by cosine of theta, which is going to again give us a negative CX component. And we can see that we can define CY, and CY is going to be the magnitude of C multiplied by the sine of theta. And because the angle is greater than 180 but less than 270, then our Y component will be negative, which means that the overall vector C is pointing to the left and down. Finally, we can consider vector D, where vector D is going to point into quadrant 4. We're going to define the angle the same way. So east is going to be 0 degrees, and we'll go counterclockwise until we run into the vector. So now we can see that our angle is greater than 270, but less than 360. dx will be defined as the magnitude of d multiplied the cosine of angle theta. And we will have dy, where dy is going to be equal to the magnitude of d multiplied by the sine of theta. And as we've seen with the others, because of the angle, we're going to end up with a positive x component and a negative y component, meaning that our vector is pointing to the right and down.